So this is a disclaimer, Amanda.
Oh, sorry. We can just, this is just like the general disclaimer that we add into all of our presentations.
Perfect. So yeah, moving on. Today's agenda will first touch upon risk workshops, then we will continue to managing threats and opportunities, then we will delve into quantitative risk analysis, both in terms of cost and schedule. Then I'll touch upon risk monitoring and reporting as such question came through ahead of the session, and then we'll have some time for Q&A. So, starting with the risk workshops. So the aims of a risk workshop is to explain the key elements of risk management of the risk management plan, to guide entities through the structure and content of any existing risk register, to identify an initial list of project risks, to allocate risk ownership non-contractually, and to schedule the next risk management steps as to align with the master program and the integrated work schedule. So it's basically to start off the risk management process and to identify some risks and how we're going to move forward. So, how should we prepare for a risk workshop? Ahead of the workshop, it's important in order to maximize stakeholders' use of time to review the potential sources of risk. Uh, this this will be different from project to project, but examples would be like sending to the attendees encouraging everyone to review the assumptions log, scope of work document, any existing risk registers of comparable projects or previous phases of the same project. Some risks are occurring themes, dependencies of comparable projects, and interface documentation. Sometimes you can come up with something called a risk breakdown structure, which essentially identifies potential sources of risk in similar projects, so it can get us to think about what risks may emerge in this project. It's super important to always send a briefing note so we set expectations and that everyone at least attempts to come prepared. That's an example agenda that you can set in your risk workshop. It would be good to have like a 10-minute introduction and workshop aims to set up the aims of the day and for each stakeholder to know who is who knows what, so who would be taking upon each risk theme. Um, it would be helpful to go over the risk management plan summary because the risk management plan is set to identify exactly how risk would be managed in the project. So it's good to start by reviewing the whole process because usually the workshops to kick things off. Then reviewing top threats about 15 minutes, and then briefing the stakeholders on breaking out risk identification, and then it's usually more productive to split stakeholders into breakout rooms because it's kind of like takes off the pressure of being like in a big room and having to speak in front of everyone and people having to raise their hands and say their thing. It's you split them into small teams. You've assigned the teams from before, and this way you have more productive discussions. And then in the breakout rooms, there's risk identification, so it's like smaller brainstorming session that could be around 40 minutes. Of course, this depends on the scale of the project. The timings are just to get an idea. And then it would be good to regroup and share the output of each small team to the wider group and reach mutual conclusions and agree on the next steps. So that's an example risk workshop agenda. That's how it could look. They're usually quite big sessions. So yeah, as you can see on the proposed timings. So moving on to managing threats and opportunities. Risks can either be threats or they can still be opportunities because a risk is an uncertain event. So sometimes it's so that opportunities arise. So I'll go into how we manage threats and opportunities differently because of course they're opposite. So these are the 4 threat response strategies. We can avoid a threat. When we avoid the threat, we essentially reduce its likelihood of occurrence or impact to 0. There's a pre-threat response strategy status. So its potential to impact a technical schedule and or cost. That's what we reduce when we avoid. And the post-start response strategy status is that after we avoid the risk, there's no residual threat. We essentially eliminate it. So, transferring a threat, we would essentially transfer the whole or part of the threat to other work breakdown structures or to an external organization. So we would essentially lift it off our shoulders and give it to someone else more appropriate to deal with it. So then um so then there is reduced or no residual threat for our organization. So we can mitigate a threat where we reduce the likelihood of occurrence or impact, but we do not take it down to zero. So there's still some potential to impact, but the residual threat after we mitigate it is lower than the original threat. And if there's nothing we can do, or if the threat's not important enough and dealing with it can cost us more than the actual threat, because that is the case sometimes, we decided to accept the consequences of the threat. We accept it. So then, in this way, it still may impact the same way the cost or the schedule or the technical aspects of the project, and the residual threat is exactly the same as the original threat. So, when we have an opportunity, on the other hand, we can either exploit it, which is the most preferable, of course, share it, enhance it, or ignore it. So these are essentially the opposite strategies used in threat. So when we exploit an opportunity, we increase its likelihood of occurring to 100%. So this way, we end up with a realized opportunity. So we have enhanced technical aspects of the project or schedule aspects of the project or cost. So it's like an opportunity to save money, to finish quicker, or to have a better technical outcome. Um, we can share the opportunity because sometimes it's easier for us to work with another work breakdown structure and external organization in order to achieve the opportunity. So we don't take full credit of it essentially, but we share it with others. So we enhance the chance to realize the shared opportunity. We share the benefit with someone else. Then we can enhance the opportunity, which is essentially increasing the likelihood of occurrence or impact, but not to 100%. So then we have a greater opportunity than the original one. And if we cannot do nothing to help realize this opportunity, we ignore it. So the residual opportunity is the same as the original opportunity, and if it happens, it's a good thing. If it doesn't happen, it's all right. It wasn't in the plan. So moving on to quantitative risk analysis. So I'm going to touch upon quantitative risk analysis on cost and schedule, QCRA and QSRA. So quantitative cost risk analysis. So the purpose is to help estimate the project's likely final cost and set appropriate monetary contingencies. So we can this way review remaining contingencies post award of main works contract. The key sources of error are cost to risk, which are chance events that may or may not occur and impact the cost, and cost estimating uncertainty, which essentially is the accuracy of estimating quantities or rates, which is influenced by the project definition and estimating methods. So essentially that means that when we have our QSs or when we like estimate the cost, we are not 100% sometimes that this would actually cost as much. It could end up costing less or unfortunately more. So we need to take these into account, risks and estimating uncertainty and the potential impacts of risk to build a risk model. So um, quantitative cost risk analysis, we can model it using the Monte Carlo simulation, which essentially how it works is that you build this model and you simulate the project as many times required. It's usually 1,000 or 10,000 iterations, depending on the project, depending on the client. Um, so you put it in a software. At risk is usually used for quantitative cost risk analysis, except if you want to build a combined model with schedule, which I'm happy to touch upon, which softwares I personally recommend. At risk is a simple Excel add-on, which solely does cost. And basically in Monte Carlo simulation, you can repeat essentially multiple times the project. So each time randomly, each risk event does or does not occur based on the probability we input and the cost of various um, activities or materials falls in a different place within distributions of the uncertainty. So that's how we take risk and uncertainty into account. So the steps in terms of risk, we provide qualitative risk assessment, then we describe impact scenarios. So best case, worst case, most likely case to create distributions. Then we use like best fit probability distributions. We we quantify the risk and we build and analyze a risk model. Then after we've also added on uncertainty, we can run sensitivity analysis to identify the key risk drivers, so the key risks that would drive the cost up. Cost estimating uncertainty, we need first to agree on an uncertainty classification scheme. The one I've used most of the times is AAC, and apply the scheme to the cost plan items and build a combined uncertainty and cost risk model. So yeah, that's how we get a holistic value of how our costs could be affected. And the outputs are essentially a distribution where we could get like the P50 value or the P80 value. These means that the statistic of like if you were to run the project 50% of the times, your cost would not exceed that much. That's your P50 value. If you want to be more conservative, you can say your cost would, you could use a P80. So 80% of the times your cost would not exceed that much. So that's how what the P values represent. And you can get these sort of statistics and which risks impact the most when you do your sensitivity analysis. So quantitative schedule risk analysis, again, we do it with Monte Carlo simulation. Its purpose is to help estimate project completion dates and schedule milestones. And the sources of error would be schedule risk and duration estimating uncertainty. So similarly to cost, we've got chance events that may or may not occur that impact the schedule, and duration estimating uncertainty. We are not certain 100% about the accuracy of the task durations we have assigned in our plan. So, again, using the Monte Carlo simulation, very similar techniques, different software. Schedule's always most complex because you've got dependencies on each activity to another, where cost items, again, you have dependencies and correlations which you can model, but when you run schedule risk analysis, you've also got like links in the game and milestones and stuff that move that carry other stuff forward. So it's a bit more complex to model, and you would need a different software. So there are softwares that offer cost and schedule risk analysis together, like Saffron, but you can model schedule risk analysis on Primavera risk analysis, which is essentially an Oracle software aligning with P6 quite well, but quite outdated also because it hasn't been updated since 2012, but it's still very commonly used. So schedule risks provide quantitative assessment of significant risks. Then we describe impact scenarios. Again, similar to cost. The steps are very similar to cost. We quantify the scenarios in terms of time. We use best fit probability distributions, and we assign risks. Then that's what we don't do in cost. We do risk mapping in schedule, because in cost it just affects the overall number. That is the challenge in schedule risk analysis, risk mapping. So you need to assign risks in relevant tasks in the schedule. And then you would build an analytic risk model after you also build in the duration uncertainty. So you would agree again on a duration uncertainty classification scheme, and you would apply that to tasks. You'd prioritize critical path activities or those with minimal float. Then you would build like your combined model. You'd run the model as many iterations as required. And then again, your outputs would be similar. You'd get a distribution with a P50 date or a P80 date or all the statistics you can choose, whichever is more relevant to your project. And you can run again a sensitivity analysis and identify your key risk drivers on the end date of the schedule. So very similar again, Monte Carlo simulation. So strengths and limitations of Monte Carlo sampling. Strengths: Monte Carlo is flexible, is able to model complex systems and processes. It provides a range of outcomes with associated probabilities. It incorporates multiple sources of uncertainty and variability and is useful for sensitivity analysis, so essentially decision making, because sensitivity analysis would literally show you like a tornado chart so you can see what to prioritize. Cons now, limitations. Since it's very sensitive to data quality and assumptions. So in projects that are not as mature, maybe you don't get the best value. Um, you maybe you don't get the best value essentially out of it. So data maturity is quite important. Your output, your analysis is as good as your input, really. So quality of input plays a super important role. It can make it or break it essentially. It relies on complete and unbiased data. Yeah, it comes to the same point. It's super important, super sensitive to the quality of your input. And then current tools may not capture complex risk interactions. That, of course, depends on the tool you'd be using, because risk interactions can get very, very complex correlations between them and interactions. You can model some, but sometimes might be challenging. So that's about Monte Carlo sampling and quantitative risk analysis. And now to answer a question that came before this session, I've added a few slides on risk monitoring and reporting. So risk monitoring is defined on APM as the process of monitoring the implementation of agreed risk response plans, tracking identifying risks, identifying and analyzing new risks, and evaluating risk process effectiveness. So the steps of risk monitoring and risk review is an iterative process essentially consisting of the following 5 steps. First of all, you'd implement risk response plans. Then you would check in a risk review the emergence of new risks. You would also have to check the occurrence of risk events that had been identified. Then something that's also worth checking is the passing of risk impact timeframes. Like for example, um, each risk can like occur in a certain life cycle stage or when current activities take place. After the activity has taken place, this risk becomes irrelevant, so we can close it off in our risk register. It's not a risk to us anymore. And then reviewing, of course, the instructed changes to the baseline. So the data to be reported is captured in the risk reviews.